I'm Stefan Wald from Basis International. Some of you I spoke in the pavilion on our booth. We have the webforJ booth there, and what I have prepared for you in this talk is a talk about ways to modernize existing Java applications. That could be Swing, Eclipse RCP, Oracle Forms, or something without the reflexive reach to a React or an Angular for the front end. So what you could do to do everything in Java. Maybe a bit of show hands. Who's running Swing? Yeah. Eclipse RCP? Oracle Forms? Nobody? Something else? Okay. Okay. So the demand today when you run a business application is that it should run in a browser. Why is that? Not only because the browser is the state-of-the-art user interface for today, but also it can save you quite a bit of infrastructure costs. If you think about it, having to run a Java Swing or a JavaFX application, maybe you still need a Java runtime at the client. And many companies run in the infrastructure things like Citrix or RDP, Windows servers, or some other ways. And not only does it add to the cost to the invoice, but also it adds to the overhead for administration, infrastructure, and so on. So this is why many companies nowadays search for ways to bring their Java application to the browser. And this is what I'm going to show you in this talk. So conventionally, when teams start to explore what could I do when I have an existing Java app, think Java app, perhaps Swing, you would perhaps say, okay, UI, browser, this is what React is for. Then what you would need to do is kind of expose your business logic as REST endpoints. If you have a classic GUI app like Swing, you don't have those for everything you need. So you would have to wrap around, perhaps rewrite, do quite a lot of things, and then rewrite the UI in JavaScript. That results into having to hire people who can do that JavaScript, React, or Angular front-end code, which results in two teams. And you're looking at a kind of series of things that need to happen in order to execute on such a project. And it's time-consuming, costly, and it bears a bit of risk. So our proposal here in this talk is to do it all in Java. And we do have two products for you that you can combine to start and to execute on that journey. One is Webswing. Webswing is a product out of Europe that allows you to run an existing Java GUI app like Swing, RCP, and so on immediately in the browser. I'll show you that live in a minute. And webforJ then can be used to further migrate, because a Swing app still remains visually a Swing app. It doesn't become responsive overnight. But then you can start upgrading it. We do have, by the way, if you're curious about Webswing in particular, Andre from Webswing in the room. It's this guy over there. So if after the talk you have questions, especially about what Webswing does, he's the guy to ask. So first of all, I want to make a point for legacy. Legacy does not necessarily mean it's broken. So if you have existing code that has been written like 10 years, 15 years ago, you applied architectural principles, you have separation of concern, you have all these things, perhaps like a back-end logic separated from the UI logic, model view controller is taught at universities. It's just that all what you have does not naturally translate into what you would need for a REST backend, because REST has to abstract at other points. And that means that you have a good logic that is rock solid, that runs your business, but now you would end up having to rewrite major parts of it in order to make it usable by a framework like React or so. So you have battle-tested business logic, and you don't want to throw that away. So the problem is the delivery and not the code itself. The users also, they don't hate the app because it's Java. It's just accessing it as a GUI app becomes more and more a pain, where everything happens in the browser nowadays. So the legacy landscape that we're covering is Swing, JavaFX, SWT, Oracle Forms, and also Eclipse RCP. The OSGI framework in RCP brings a few additional complexity things because they're doing a lot with class loaders in the UI. So that means that it might not be as trivial, but basically what I propose to you today can be done with all of these existing technologies. And just rewriting it is the wrong default. So you may have something between 500,000 and 2 million lines of code, and full rewrites routinely fail. And also there is, just on a side note, a certain risk that when you decide for a full rewrite, you do have the so-called version 2 problem. Who has heard of the version 2 problem? So the version 2 problem is when people say, well, we rewrite it, so let's also put in all the features and functions that we didn't have in the past. And then you have also scope creep, and the project gets bigger and bigger and bigger, and actually it never ends. And then also in companies, what we see, you have a brain drain. The people who wrote the original code, they left the company long ago or leave over time. And that also means that you miss quite a lot of the institutional knowledge that is in your logic. And also, alone, when you want to redevelop something that exists that took years, it will again take a long while until you're done. And during that phase, you have to maintain both. And that's a problem for not only ISVs who have to ship and sell, but also for large-scale own applications. So the other point I want to make is the multi-stack tags a little bit closer in the look. So if you have a Java team and a separate JavaScript team, when I say JavaScript, think React, Angular, whatsoever, they have to work with each other. And I don't know, some of you may have encountered situations where the backend team says, oh, there's something not right in the front end, fix that. The front end team comes back and says, well, it's your backend that's not right. And then they have to negotiate and try to debug something. And when you're in such a scenario and you look at the UI, you cannot simply go to your IDE, set a breakpoint, and make the program halt. So it's much harder to debug and to kind of find a reason for a misbehavior. Whereas in Swing or in some others, you have the regular debugging of a GUI IDE project. So all these things kind of make the case for looking closer in a concept that allows you to do it all in Java and in one code base. And I'm not saying I endorse writing spaghetti code. I still make a strong point for keeping separation of concerns and separate the UI code from the backend code. But what I suggest is for the redevelopment, do both in Java and let Java do the work for you. Then a few things that others have tried. So we have consulted with a few of our long-standing customers. I must make the point that Basis International, the company I'm working for, is around for 40 years now. And so we consult with companies of different sizes, and sometimes we help them and consult with them in selecting or evaluating certain technologies. And as part of that, I was doing a project with a larger ERP vendor out of the Netherlands, and I have these as a showcase later. And they looked at low-code platforms. And so the caveat with low-code platforms is they get you started pretty quickly, but as soon as you reach a certain point of what their platform provides you with, then you get stuck, and it gets much, much harder to get the last mile done, because very often these platforms are opinionated, and what they don't solve for you, you have to fight the platform to get what you really want done. And then also for an ISV vendor, especially, they add a steep cost to the infrastructure cost for the platform itself. And then we spoke about React and Java backend. You have a modern UX, but you have the multi-stack tags having to maintain 2 code bases, 2 teams, 2 knowledges, 2 technologies, which over time will increase the cost for the maintenance. Then there were things like GWT. Anyone tried GWT in the years here? So you probably will admit that this is not the way to go in 2026, because GWT has come to age, it has been discontinued, but this was one of the first platforms that allowed a Java development for the UI. It had some, I would say, it required some longer compile times and so on, but it's largely abandoned, so you wouldn't start a new project. And individually, you might have looked at certain other choices, which I'm not going to list many more of those, but you got the idea. So what we're looking at today is a combination of using Webswing immediately to bring what you have to the browser, to the web, and then start your migration path, your modernization path, building for tomorrow in a stepwise fashion at your own pace with a lower risk. You reuse your business logic. If it's written for a GUI type thing like Swing, webforJ as a framework can do a great job here because you can reuse much of your backend logic. If you're already using things like Spring Boot for your backend, then even it's better. So it integrates quite well. What is Webswing? Let's start there. You do have an existing application in the browser by Webswing, so it could be Swing, JavaFX, Eclipse SWT, NetBeans, or even applets. I mean, you probably don't have any more of those, or even Oracle Forms. And just by installing Webswing and by configuring your application with the command line, it runs in the browser. How does it work? So Webswing injects at the rendering layer, so at the AWT layer, and what they do is basically they grab the information for the rendering, like render a button, render an input field or whatever, and then they render in the browser on a canvas. So it's, think like RDP for Java, if you want to translate that. And so this is what you have today. You see this desktop application, the GUI, and with Webswing, there is the Webswing server in the middle. By default, it comes with a bundled Jetty, and then the client side can be, or would be, a browser rendering the Swing application on the client. So the rendering on the Java part happens on the server, and then what they do is they transport the information to the client. And I'm going to give you a quick run how it looks, because I think it's worth looking closely at it. So this is the Webswing admin front, and I just grabbed the admin, the Webswing binaries from their download page. You can go there, download a demo today, and then there is a demo version where you have some demo applications exposed. I'm going to look at one of those, just the core demo. And you see there are certain configuration steps. I'm not going much into detail, but in the app config, this is where it gets interesting. You have, besides the working directory and the JRE executable, you have your class paths. This is where you would basically put in the jars that you need in the UI layer to execute, and the JVM arguments that you need. In this case, for the demo, I don't need any. And there are certain other settings that I'm not going too much into detail. It's well documented. And then after doing that, I can just click the link, and here is the running application, the Webswing demo. You see the Swing application running in my browser. So this is Swing, and you see even with the animated what is it, the Duke, it was quite quick here. And of course, it's local. But it's also equal to like a Citrix when you are in a remote deployment setting. So it's really fast. And what you see here is also, I'm running on a Mac, so the look and feel does not become browserish. So it's still the look and feel and the non-responsiveness or responsiveness of your Swing app. It's not going to gain anything in that direction. And also the demos, when you look here at the applications, you see there are others like the NetBeans platform or Eclipse RCP. That's another demo I could try running for you. So you see it's taking a moment. And here's an RCP application. It's a simple demo that is written using the Eclipse RCP framework. So really out of the box, just configuration only, and then you can just run it immediately in the browser. Where were we? So the framework that would start with Webswing starts with enabling your application for the web, for the browser. So it's an easy overnight step. Download Webswing, go and configure your application and deploy it to the browser tomorrow. The session handling, login integration, also Webswing has a very well-documented API, because when you bring a Swing application or a desktop application to the browser, certain things are different, like file handling. File opening, file saving becomes browser uploads and downloads. And Webswing has solved all that for you. So there is an API that lets you even implement some specific behavior if you like to adjust it, but out-of-the-box defaults there are already very versatile. And then what you can do, and this is what I'm going to talk about next, is you would basically start extending the existing application, the existing Swing application, the existing RCP application with new modules, or you replace them, or what you add for the future, you immediately start with a new stack that gives you a modern, responsive user interface. And this modern user interface then would, over time, give your application a natural facelift. And they would become responsive and also better looking over time. There is some trade-off, but it's a logical trade-off. I just mentioned it. A Swing app in the browser still is a Swing app in the browser, so it will not, over time, just automatically look browserish. So this is natural. What we do have for this transition journey is a modernization framework where Webswing and webforJ integrate with each other. So what does this let you do? So imagine you have a Swing application that has a search button. So like search for a customer, search for something. You want to make this search modern, maybe apply some AI or whatever. And what you can do is you can then make calls to the new screen written in webforJ for the browser from your Swing application, and call it, and then also return the results back to the to the Swing or RCP application after the user has used that new implemented screen. It also works the other way around, so you can also start with a new implemented screen, and when you need to embed or to open a legacy window from your Swing application, and when I say Swing, think RCP or the other that I named, then you can do the same. So this is just a sample snippet of the Webswing connector in webforJ, and this is showing just how to embed a Swing app. So a thing like I deployed it before, it takes the URL under which the app is deployed. It has some options that I'm not going into detail here. And then what it does is it embeds the screen in a modern application. So you have your new UI, and then it renders a little canvas with the Swing application. And I'm also going to show you that. So there is webswing.webforj.com, and you can try that out yourself if you like. So you see it's starting up the Webswing screen here, and you see on the left this is a JPanel. So it's a very simple app for demo purposes. We kept it simple so that everybody can understand. And when I select a record here, you see that on the right it's populating the form. And when I make a change here in the form, let's say this is in the future, just for the sake of, it's basically going back. And here is really where the integration has its strength. When you go to the Webswing site, you will see they also offer integration like this with React and Angular. What we can do here, we can serve the application from the same web server, which lets you share the class loader. And that lets you share classes and even instances of the objects on a shared class loader, which is a strong benefit for state management between old and new. So it requires a little bit of architecture and planning, but if you have a very large application, it might be beneficial to share things like the session context or user information or stuff. So because then you're running from the same web server and you have this shared class loader possibility. But this is, I think, a pretty strong possibility, and now having this at hands for a developer, the sky is the limit. Going back to my presentation. So let's speak a little bit more about webforJ. So webforJ is what I suggest you might want to look at as a next step in a modernization journey. So remember, we use Webswing to get to the browser what you have today. And with webforJ, you get a modern UI framework written in Java for Java developers. It's component-based. It feels like Swing, or you might hate me for that, a bit like Visual Basic maybe even, where you just start a form, put a button on it, register an event, and let the framework do the magic for you. And it's built on the dynamic web client, which is a set of HTML5 components that Basis International did create not only for webforJ, but also for our other product lines. And they are production-grade, themable, and they are covering all the components that you would need for a normal Swing app that you might have in-house. The webforJ is also supporting Spring Boot or Spring. You can drop it into an existing backend, and we also support Kotlin DSL, and we do have AI tooling and MCP integration available. And what I have took out for you as a close-up is the similarity between a Swing and a webforJ. So in Swing, you would just have a J button, and then you add your action listener, where you do whatever you would do in the action listener. And you see here also in webforJ, you just create your button on the screen, and then you register the click event. So they translate pretty much one-on-one. We didn't choose the same naming as Swing, but they are translatable. And it's the same mental model. The framework handles the browser, and the layout can be responsive now. You don't have to write CSS by hand, but you can inject CSS if you wish to. We try to avoid having people to write JavaScript CSS, but if you like or need, then you have the full freedom and the full control over the browser. We do have data binding. We can bind beans to a form, routing, navigation, deep links, all the things that you would expect from a web application are available. Another close-up. This is a sample that tells a little bit more about how webforJ works. So in the middle, you see a simple counter app, one that many people wrote when learning. You have this button, and when you push the button, it's counting up the text in the middle. And when you look at the left, this is all the code that makes this application. It starts with the run method, which implements how the screen is scaffolded. We have the frame. On the frame, we put our text and the button. And then all we do here is we add a click listener, and in the click listener, we count up the variable and update the UI. And this is going to be compiled into a WAR file by default, which you drop into a Jetty or a Tomcat. And when the user clicks on that URL or visits that URL, the framework scaffolds the app in the browser, it renders the UI, it creates the button, it creates the text with a JavaScript thin client, and it also then responds to the events. And when you click that button, then it's basically finding that event listener on the server in the Java code and executes whatever you put there, which means that where it does here count ++, I mean, model view controller, we have a very simple model, just a variable, but you would here probably have a Spring service or whatever, a Pojo class that does something, can be anything that you can import in this program, because it's a plain vanilla Java program. And the beauty of this is You just go set your breakpoint here in a point that interests you, and then you start the app in the browser, and when it reaches and hits the breakpoint, your IDE will start and let you inspect the variables and everything. And you cannot easily do that with a REST backend that serves a React or an Angular app. This is much harder there to debug. So the debugging is really easier. And you see here, there is no CSS and no JavaScript necessary, all in Java, and all that's needed is this little piece of Java code to come to that result. Now also here, while it's modern in the web UI, you have a full Java stack, so we have addressed the concern with the two teams, the split brain. We can do an incremental adoption. We have Spring, Kotlin, AI tooling, all the things we need. But now we're actually redoing the UI layer of the application. So this is a migration that can be assisted by AI, but that means you're implementing something new. But yeah, you want to have it responsive in the next iteration. I mean, you don't want to have a fixed screen with a bit limited layouting of a Swing app. You want to have something browserish with drawers and things that collapse and accordions and the things. So you would then go much more crazy and fancy with your new UI here. But the learning curve is really short. The experience tells us that somebody skilled in Java who has done things like Swing can pick it up pretty quickly, pretty easily. So the migration, again, Webswing, unchanged code. You go hybrid with the connector, and then at some point you may or may not reach the pure webforJ implementation. And some people may only attach or address screens that are relevant for daily use and may retain some secondary or not so important screens in Webswing forever. So why touch something that is not used every day by many users? Webswing is a good carrier for giving the existing code a second life. So the three scenarios give you in one strategy, give you a strategy that buys you time, because you can be virtually in the browser tomorrow if you like. I'm more conservative on the slide here because I don't want to be held liable in court for it, but I say weeks, but it's really as easy as I showed you. And then for the incremental, starting to have quick wins, quick first new screens, we're talking of months. You need somebody who champions the effort, who learns the framework, and then who starts making the new screens. And then you can have your hybrid. And also when you have new modules, greenfield modules, after you have this stack in place, nothing holds you back from immediately doing new initiatives in the new stack. That's also then immediately available. I do have a sample for you from one of our Dutch customers. Prodin is the name, Prodin VV. They also are around for even more than 40 years. I think they even predate our foundation date. And with what I just proposed or showed you, they are on the web now for the majority of their code. So it's an ERP provider who has an ERP for field services, manufacturing, a little bit of wholesale. But they're mostly in field services and manufacturing area. And they came from a non-Java ecosystem in the early 2000s to Java with a Swing application and a Swing UI, and they have decades of business logic that has been translated and transferred to the Java ecosystem. And from their Java code, they even inherit some of the older code with some specific technologies. And so they have evaluated low code that would have required a full rewrite, and they found it quite constrained and limited. As an ERP vendor, they wanted to have more control over how the UI looks, how it behaves, and they also have some, especially for the manufacturing, they had some requirements to be a bit more versatile with the UI. And then they evaluated Angular and React, and they quickly also found themselves in this multi-stack thread. And then the owner, Patrick, I'm working with, he also at some time said, well, he observes the people talking to each other about details and who is responsible for what and where should what logic reside. And that's also something that he said would be untenable for long-term strategy. And so they chose webforJ to keep a unified Java stack and to reuse the existing logic. And just a few pictures here. So this is a screenshot of their latest Swing user interface. So you can see from the icons that they try to become a little bit modern with Swing, but with mixed luck and success. And you see it's an MDI window with a menu on the left and with MDI client windows that can be popped out. And they were opting for a similar user interface in webforJ. So they re-implemented the menu with for a user that has all access rights, the menu on the left has more than 500 entries. So it's a very comprehensive system. And then they start to redo screen by screen. And while they do that, they reconcile certain screens because they want to now benefit from the browser and from the capabilities. So rather than having the classic, not so much workflow-oriented implementation of the older times, at the time that they go to the browser, they go more to a workflow and also dashboard-driven type of approach. But they do it step by step. They're still not 100% done in manufacturing. In some floors, they still run the old Java UI, and they just go at the pace that the business allows them, and that turns out to be the right approach for them. So their numbers in particular, after 4 months into the project, with 6 developers on the Java team, with 0 lines of JavaScript code, they were able to ship the first modules with webforJ. And that was really stunning, and that reaffirmed them in their selection to go with the single stack Java approach. And not only webforJ offers that, but the really key is here that you will want to be in a stack that allows you to reduce complexity, to reduce the effort that it means over years. A fun side story, I was running into a CTO who became a friend of mine, and when we met, he told me that he would allow his engineers to introduce a new technology or framework every year, because he was afraid that they would run away if he would not give them the opportunity to learn something new. And we know young people are keen to learn, explore the next new thing around the corner. And I just told him, well, but how do you maintain these things in 10 years from now if you have added 10 more technologies and the people who had the idea this year, they long left you and they are somewhere else? And he admitted that he had no answer to that. And I think genuinely it's a bad idea to do that. And I always think, also at home, by the way, and my wife loves me for that, when I want to buy something, I think twice, do I want to let this into my life? And what does it mean in the long run if I have to nurse that little pet forever? And it's the same with frameworks. So don't always go for the next new thing, especially for UI, and think about maintainability, especially in a large project, in a large-scale project. So it's really very important. So your Monday morning action plan for next Monday, when you get home from the conference, identify your most urgent legacy app and run Webswing locally with it. Deploy it, go there, try it out. Trust me, it's easy. Do the download and try it out. Then go on docs.webforj.com, have a look at the Getting Started guide, scaffold your first Hello World, or let me show it to you when I close the talk. It takes less than a minute to get started on webforJ. And then read the Webswing connector tutorial, how to connect both, try it out, and then talk to Andre or us. We're here on the conference to help you out. Unfortunately, the conference exhibition is closing after this talk, but we're still around, and I will be here tomorrow. If you need to see me, just text me on LinkedIn or so, and I'll be here. So now, before I come to the end, I am done with my slides. I will be brave and do a little bit of live coding for you. Let me start my IDE. and show you how to scaffold a project with webforJ to also give you an impression how easy and simple it is. So let's just say new project, and let's say session. I just give it an arbitrary name. I choose Maven Central and search for webforJ. And I'm just searching for the, what do? We do the side menu sample. I leave the defaults down there for package name, app name, and so on. I think you can try that yourself. I just say create and let the IDE do its thing. In the meantime, while it does that, I stop Webswing because they're defaulting to the same port. Who is annoyed by everything taking 8080? So here we are. It has scaffolded the app, and when you look here, it has created a few Java classes. There is an application class, which is just a stub, and we have here a program with a few views, and each view panel is just in the style of what I showed earlier on the slide. Now let me just run this. I did use the plain vanilla implementation, which comes with no dependency on Spring Boot, nothing. So it's just plain Java code. And so all I need to do, we bundle in Maven the Jetty plugin. I just say Jetty run, let it do its job. And then while it starts here, I go to the browser and go to 8080. And here's our application. And now I can go ahead and change the views and open my database, connect to Spring, whatever, and populate the screen. So that's really, really easy and quick. And I think you can do that Monday afternoon after you have installed Webswing. And so this is my proposal to you. Try it out and consider the stepwise approach of, here we close with this slide, not with the last one, with web enabling with Webswing, extending with webforJ, giving it a facelift, and then a rebuild. So I'm at my end with the demo, but I'm very open for questions because we ran a little bit early out. I think talk is over before people wish it would be over. I hope that's the case for you. But give me your questions if you have any. Yes, thanks for asking. So first of all, I heard you saying more timely. So we're as timely as everything else that you can get on the market. But having said that, I have run a talk on, what was it, DevOps London, where I was comparing a project back-end Spring with React front-end and compared to the same project in webforJ, and the power was in the reduction of the lines of code. So and also in resulting in the time it took the engineer to build it. So we had, and I could see if I can find the numbers for you, maybe after we close. The talk is, by the way, on YouTube. The numbers say that we are cutting the time it took to implement the application in half, basically.
I'm not sure you answered my question there. But
maybe I didn't understand it correctly.
I didn't mean timeliness, I mean time leaf.
Time leaf. I didn't.
HTMX.
Oh, yeah, I didn't make the comparison right away, but I do know that time leaf has a similar concept from kind of a templating engine to go there. But we haven't compared directly with this particular one. Okay, so but I did not acoustically hear it correctly. Sorry for that. Okay, so I think if there are no more questions, let's close. Thank you for being here. And the exhibition is still open for a while, so those of you who want to check with us, there's the opportunity is now. You find us in the pavilion next to where they do this premium coffee or hot chocolate. I had a hot chocolate that was also good. Thank you.